Today we are solving questions of mean value theorem, that is all MCQs related questions. This is also as similar as Rolle's theorem. So what is mean value theorem? Mean value theorem, given function f is continuous in closed interval AB, differentiable in open interval AB, then there exists a C belongs to open interval AB, same as Rolle's theorem, right? Such that f dash C is equal to, in Rolle's theorem, 0, and in mean value theorem fb minus fa upon b minus a, right? So fb minus fa upon b minus a, this is the mean value theorem. So we have to check this. So f is a polynomial function, so as usual it's continuous function and differentiable function. So here f is polynomial function, f is polynomial function, therefore f is continuous in 1,4, f is differentiable in open interval 1,4, right? Therefore by Rolle's mean value theorem you have to verify f dash c is equal to fb minus fa upon b minus a, so you require f dash x, right? So therefore all conditions of mean value theorem, I am writing MVT, mean value theorem, satisfied, right? So therefore mean value theorem is applicable, mean value theorem is applicable. So what you require now, f dash x, fx, right? So now fx is equal to, what is given? Fx is given x square minus 4x minus 3. So x square minus 4x minus 3. Therefore, f dash x is equal to, right? Either you can write here also. F dash x is equal to, derivative of this is twice x minus 4. So twice x minus 4. Now you require f of a and f of b. That is f of a is equal to f of 1. 1 minus 4 minus 3, you have to substitute 1 here, right? So 1 minus 4 minus 3, that is 1 minus 7, that is minus 6. So this is minus 6, and FB is equal to 4. So f of 4 is equal to 16 minus 16. 16 minus 16 minus 3, that is minus 3, right? Therefore, by mean value theorem, f dash c is equal to fb minus fa upon b minus a upon b minus a. Now f dash c, that is twice c minus 4. So therefore twice c minus 4 is equal to fb is minus 3 minus f of a is minus 6 upon b is 4, a is 1. So 4 minus 1, that is twice c minus 4 is equal to, this is minus minus plus 6 minus 3 divided by 3, that is 1, taking 4 to right hand side. Twice c is equal to 5, twice c is equal to 5, that means c is equal to 5 by 2 belongs to which interval is given? Open interval 1,4. Is 5 by 2 belongs to this? Yes, then this is your answer, right? So this is very similar to Rolle's theorem questions, mean value theorem, right? Now second question is this: fx is equal to x cube minus 5x square minus 3x, and given interval is a comma b is 1 comma 3, right? So f is continuous, as you know this is a polynomial function, right? Continuous in closed interval 1 comma 3. F is differentiable in open interval 1 comma 3 in 1 comma 3, right? Therefore all conditions of mean value theorem satisfied, right? So all conditions of mean value theorem are satisfied. Therefore mean value theorem is applicable. Mean value theorem is applicable. Here we are missing R. It's okay, no problem for grammatical mistake, right? So mean value theorem is applicable. Then what we have to do? We have to differentiate this function. So fx is equal to, now fx is equal to x cubed minus 5x squared minus 3x. So derivative of this, that is f dash x is equal to, this is 3x squared, right? So 3x squared minus 10x minus 3x squared minus 10x minus 3, derivative of this. Then fa and fb. Fa, a is 1, b is 3, right? So f of a is equal to f of 1 and f of b is equal to f of 3. So 1, substitute x equal to 1 here. What we get? 1 minus 5 minus 3. So 1 minus 5 minus 3 is equal to minus 7. Minus 7. Now 3, 27. So 27 minus 9 into 5, 45, and minus 9. So this is 54, right? 27 minus 54 is minus 27. So this is minus 27, right? Therefore, by mean value theorem, right? There exists C belongs to, and we have forget here. There exists C belongs to open interval which 1, 4. By mean value theorem, there exists C belongs to open interval 1, 3 such that it is not necessary to write because we are checking here. So that's it, okay, right? Such that f dash c is equal to fb minus fa whole upon b minus a. So f dash c is this, that is 3c square minus 10c minus 3 is equal to f of b. F of b is minus 27. So minus 27 minus f of a is minus 7, that is plus 7 whole upon b minus a. B is 3 minus a is 1. So this is 3 minus 1, right? So this is 3c square minus 10c minus 3 is equal to, this is 7 minus 27 is minus 20. So this is minus 20 upon 2, right? That is, this is minus 10, right? So what we get here? Therefore 3c square minus 10c minus 3 is equal to minus 10, is equal to minus 10. Taking 10 to this left hand side, this will come plus 10, that is 10 minus 3 is 7. So 3c square minus 10c plus 7 is equal to 0, right? Plus 7 is equal to 0. Now 7 3s are 21 and 7 plus 3 is always 10. So factor of this are 3c square minus 3c minus 7c plus 7 is equal to 0. So taking 3c common from here, this is 3c, c minus 1 minus 7 common, c minus 1 is equal to 0. So again c minus 1 is common. So c minus 1 is common. This is 3c minus 7 is equal to 0. That is either c equal to 1. So c is equal to 1 belongs to open interval 1, 3, or c is equal to 7 by 3. From this 7 by 3 belongs to open interval 1, 3. Now verify, is this one belongs to open interval 1, 3? No, because this is open interval. So boundary values are not considering in open interval. So this is not belongs to. So therefore 7 by 3 is 7 by 3 is 2 point something is lies in this interval. Yes. So therefore c is equal to 7 by 3 belongs to 1, 3. So this is your possible answer, right? Then question number 6, same as we saw in rules theorem. First, box x, that is greatest integer function, and you know greatest integer function is not continuous, same as rules theorem, not continuous in not continuous at integers that is integers means 6, 7, 8 and 9. So that is not continuous means condition for mean value theorem is not satisfied, right? Therefore mean value theorem is not applicable. So we have to do yourself. Then second, same interval minus 2 to 2 as in Rolle's theorem. So you can, and this is you have to verify like this. Two examples, right? So that's it. This is enough for mean value theorem, and we are proceed further for another extra MCQs of mean value theorem in next lecture. Next question is find the mean value of C by applying mean value theorem to fx is equal to 2 sin x plus sin twice x for 0, 2 closed interval, right? So first of all, f is continuous function in 0, pi and differentiable in open interval 0, 5, right? That you know. So here f is continuous in closed interval 0, pi, right? F is differentiable in open interval 0, pi. Therefore, all conditions of mean value theorem, therefore, all conditions of mean value theorem satisfied. Therefore, mean value theorem is applicable. And if mean value theorem is applicable, then you have to differentiate this function with respect to x. So now fx is equal to 2 sin x plus sin twice x. So differentiating this function with respect to x, that is f dash x is equal to 2 cos x, and you know this is a differentiation of sin twice x is cos twice x into 2. So this is 2 times cos twice x, right? So taking 2 common, this is 2 common, cos twice x plus cos x. I am writing this cos 2x first, then this, because in trigonometry you have to remember this thing also, that you have to keep always a big angle first, right? So now this is cos c plus cos d, and formula for cos c plus cos d is equal to 2 times cos c plus d by 2 into cos c minus d by 2. So this is the addition to multiplication rule, right? So this is your formula. So applying this formula, what we get? This is 2 times cos c plus d, that is 2 plus 1, 3x by 2. So this is 3x by 2, and this is cos 2 minus 1, x by 2, right? Therefore, by mean value theorem, what we require? Therefore, by mean value theorem, there exists C belongs to open interval 0 to pi, right? So open interval 0 to pi such that f dash c is equal to fb minus fa upon b minus a. This is your mean value theorem. So what we require now? f0 and f pi, that is fa and fb. So fa is equal to f0 is equal to, so f0 sin 0 0 sin 0 0, so 0, and fb is equal to f pi is equal to, say, sin pi 0 sin 2 pi 0, so answer is 0, right? So therefore oh, no need to right, we have to find out, we are applying mean value theorem, not Rolle's theorem, right? So fa and fb both are 0 here, right? So fa and fb both are 0. So f dash c, so f dash c is this, that is 2 cos 3c by 2 into cos c by 2 is equal to fb minus fa, 0 minus 0, upon b minus a, that is pi minus 0, that is 0, right? So everything is 0, that is 2 goes to the other side, is also 0. So cos 3c by 2 is equal to 0, either cos c by 2 is equal to 0, right? So cos is 0 for pi by 2, in this interval 0 to pi, only one value possible, that is pi by 2. At that point cos is 0. So therefore 3c by 2 is equal to pi by 2, or here c by 2 is equal to pi by 2. That is 2 to cancel, 2 to cancel. C is equal to pi by 3 belongs to 0 to pi, or C is equal to pi belongs to 0 to pi. Now decide which value is possible. Is pi by 3, that is 60, belongs to 0 to pi? Yes. So this is possible. And pi belongs to this? No. So possible value of C is equal to pi by 3 belongs to 0 to pi. Right? So I hope that you are understanding what to do in mean value theorem. So it's very easy, and these all questions are important for MC, because you have to find out only this. No need to write this on everything. Just differentiate and write down your answer. That is, if you have to find out C. Right? Question is, for the curve y is equal to fx is equal to x minus 3 whole square. So curve is given y is equal to fx is equal to x minus 3 whole square. Right? Tangent at which point? Tangent at which point is parallel to the chord? Tangent at which point is parallel to the chord A21 and B41? So this is a nice question of mean value theorem. This is a geometrical interpretation of mean value theorem that you know. Tangent at, see, tangent at, right? So tangent at any point. That point we have to find out. At which point? At which point is, now tangent at any point is parallel to the chord, is parallel to the chord joining A and B, is the geometrical interpretation of, see here, suppose this is y equal to fx curve, this is A and this is B, so this is chord AB and tangent is this, then this tangent is parallel to the chord joining A and B is the geometrical interpretation of mean value theorem. So this is the application of mean value theorem, and this type of question is very important. Right? Remember this thing. This type of question is very important for your competitive exam, and particularly for JEE. There must be at least one question each and every year of mean value theorem. Right? So this is the application. Means this is f of A, this is A, then this is f of A, this is B, then this is f of B. 2 points A and B, right? As we saw in geometrical interpretation, right? So this is A, then this is f of A, this is B, then this is f of B, right? So interval is 2, 4. In interval 2, 4, value of f of A is 1. Substitute either here, you will get also answer the same. So no need to find out f of A and f of B. It is given directly here in point, right? So now this is y is equal to fx is continuous function and differentiable function in interval 2, 4. So f is continuous in closed interval 2, 4. F is differentiable in open interval 2, 4. Right? Now fx is equal to, what is given fx? So no need to write. Mean value theorem is applicable. We know that. That's why I am writing directly. Fx is equal to x minus 3. This is your result number 1 whole square. So f dash x is equal to 2 times x minus 3, and derivative of x minus 3 is 1. Now f of a, that is f of 2 is equal to 1 is your f of a, and f of b is equal to f of 4, and that is again 1, right? Therefore by mean value theorem there exists C belongs to open interval 2, 4 such that f dash C is equal to fb minus fa upon b minus a. So f dash C is 2 times x minus 3. So this is 2 times c minus 3, because we are writing f dash C. This is f dash x is equal to fb. Fb is f4 is 1 minus 1, that is 0. 1 minus 1. B minus a, that is 4 minus 2, right? That is 4 minus 2. So answer of this is 0. That is 2 times c minus 3 is equal to 0. That is c minus 3 is equal to 0, right? So this is c is equal to 3 belongs to 2 comma 4. So c is 3, that is you get the value of x. We have value of x. So therefore x is equal to 3. So this implies from 1. This implies from 1. y is equal to 3 minus 3 whole square, that is 0 because of 1. So therefore required point is x comma y is equal to 3 comma 0. So this is required point is x comma y is 3 comma 0. So this is nice application of mean value theorem, and remember this thing, right? Sometimes what you are doing, you are going to find out the slope of line joining these, then is parallel, then you are taking f dash x is equal to 0, that is slope is 0, and then you are going to find out that value of c, but that is not a proper way to solve this example. So remember this thing, it's very important example for your MCQ and board exam point of view. Okay, there is no sum in your textbook for practice, so I give you 3 more sums for practice, so do at home. Okay.